Advanced scripting, the old school trap construct. Now, this is something that was introduced in PowerShell version 1. It still exists. They hate taking stuff out, but it's kind of, I don't want to say deprecated, but it's a little outdated. Try catch is definitely better, but you might see it sometime, so I want you to at least know what it's doing. So we'll talk about the flow of execution when an error, an unhandled error occurs in a PowerShell script or function, and you wind up catching it with a trap construct. We'll also talk about the difference between trap and try catch. Again, I'm not saying this is bad, but this is a lot more flexible, as I think you're about to see. Let me emphasize again that what we're going to be covering is an outdated technique, okay? So I just want you to know what it does in case you see it. It's still useful. I mean, it still works. It's not as elegant as the try-catch business. So here's how this works. Let's say I have a script. And in this script, I'm going to define a trap block. And then sometime later in the script, I'm going to call some external function. All right, so let's say that that external function lives over here. Function do something. And I have it run some command. Get thingy from computer name Bob. So let's say this causes an error. Here's how Windows PowerShell will work. Now, first of all, non-terminating errors will not trigger this. So I got to make sure this is a terminating error, error action stop. If the command is already internally throwing a terminating error, then you don't have to add error action stop. But if it isn't, and most commands by default don't, you have to add error action stop. Okay, so PowerShell runs this. Here's where we start. We run my script. Okay, great, you've got a trap block. I'll keep that in mind. Now we're going to run do something. Okay, that's defined over here. So we're going to run do something. Here it is. Here's the command. Oh my goodness, an error happened. But it was a non-terminating error. But you made me turn it into a terminating error. Here's the flow. First of all, was this contained in a try block? Because if it was, I'm just going to execute the corresponding catch block and be done with it. But it wasn't. Is there a trap defined within the current scope? Nope, I haven't seen one. Here's an important trick. An error occurred. It's non-terminating, but you made it terminating because of error action stop. Is it contained within a try block? Because if it is, I'm just going to execute the corresponding catch block. No, it isn't. Is there a trap defined in the current scope? No, because I haven't seen it and I'm on line 4. I didn't see it up here. I'm not going to go looking for it. I have to have seen it before the error occurs. So the answer is no. There isn't a trap defined in the current scope, meaning this error is unhandled. Nuclear explosion. We leave this function and go back and return the error to the calling script. Now this script has an error. Hey, you've got a terminating exception. Is it contained in a try block? Because if it is, I'll just execute the corresponding catch block and be done with it. But no, it isn't. Is there a trap defined in this scope? Yes. I remember seeing it when I started. So I'm going to go back and now execute whatever is in this trap. And I will, in here, have access to error 0, just like I normally do. So as we talked about in the previous nugget, that's how you can get to the error record so you can decide what happened. And at the end of this trap, one of two things has to happen. I either exit using the word continue or I exit using the word break. If I exit using break, I'm going to pass that same error record up to my calling scope. Now, assuming that we ran this from the shell, untitled 2.ps1, break would toss the error. It would stop executing this script. So whatever happened down here, this would never run. The error happened here. It wasn't in a try block, so I looked for a trap. I found a trap. I did this. And then let's just say I hit break. I'm leaving my script. I'm going to pass the exception up to here and see if the shell wants to handle it. If the shell doesn't, then it'll just display the error and it'll all be over. I can still do other stuff here. So it often doesn't make sense to break. You only break if you've looked at the error and gone, game's up. There's no point in playing with this script anymore. Nothing good's going to come of it. I just want to leave. Break. Your other option at the end of the trap is continue. Continue says, okay, do something. Here we go. We're in here. We're doing something. An error occurred. It's non-terminating, but you made it terminating because of this. Is it in a try block? No. Did I see a trap yet? No. We're tossing the exception back to the calling scope. Terminating exception on line 8. Is it in a try block? No. Is there a trap? Yes. Do this and then continue, which means resume execution on the line after the one that caused the problem in the same scope. Meaning I'm now going to run line 9 because in this scope, line 8 is what caused the problem. I am not going to re-enter the function. All right, let's walk through that again. Run this, that runs this. Error. Didn't handle it in here, so I'm tossing it back to here. Error on line 8. Handle, handle, handle. Continue. Line 9. We aren't going back over here. This will never execute. All right. The whole back and forth in the way that scope plays into this thing makes trap really difficult. It also makes it a little bit hard to handle multiple different types of errors because you sort of just have this one high-level error thing. All right. If we had a problem here, this would execute. If we had a problem here, this would execute. So there winds up being a lot of logic in here to figure out what went wrong and what you want to do about it, which is why try-catch is so nice, because with try-catch, I can have separate handling for each thing that might go wrong. If something goes wrong here, do this. If something goes wrong here, do this instead. That will always override. It will never have to go for this trap. About the only time I think I see folks use trap now is to provide kind of a last-ditch mechanism for perhaps writing an event log entry about the error, meaning I'm in this script, something went wrong here. I wasn't expecting it. You can tell because I don't have this wrapped in a big try block. And so I'm just going to pop up and do this instead. But there's another strategy for that people will use too. It's PowerShell. There's 20 different ways you can do anything. They'll do this. This ran without error. Oh, I had an error. Is it in a try block? Yes. Execute the corresponding catch block and write a generic error to the event log or whatever it is you want to do. And this kind of, because everything now is in a try block, it eliminates the benefit of even having a trap construct there. So, don't want to save that. So that's what that thing does. So even though it's outdated, again, you might run into it. You might grab someone's script off the internet that uses a trap construct. So now you at least understand the flow of execution with that thing. And you understand the differences between trap and try-catch. I think try-catch is a lot more flexible. You can be a lot more granular with it. And there are still folks that use trap as kind of a high-level last-ditch catch-all, but I think for the most part, people really prefer try-catch. Try-catch is definitely something that exists in a lot of programming languages, so it's kind of much more standardized and much more widely understood than trap. Trap is only in there because it's kind of the best that the team could do in the timeline they had to ship version 1. As soon as they had time, i.e. version 2, they did try-catch, and that's what I think most of us would like to use these days. I hope this has been informative for you, and I'd like to thank you for viewing.